Hello, everyone. So a student asked me about this question, homework problem, and I thought it was talking about. There are a few things I wanted to talk about, so it's probably better to just record it. Okay, so let's read this problem. An urn contains 21 balls, of which 13 are white, and we can call the other 8 red, because actually we have A, B, C, 3 people, so I don't want to use B, black. So we have 21 balls, in which 13 are white and 8 are red, not black. And then we have A, B, C, 3 people. They're gonna draw a ball one by one, according to this direction, so A, B, C, and so forth. The winner is the first one to draw a white ball. And we're looking for the probabilities of winning of each player if each ball is replaced after it is drawn. And the second case, when the balls that was drawn are not replaced. Okay, so first case, each ball is replaced after it is drawn. So once a ball is drawn and then replaced, then the situation becomes the same as it was before, and we're going to assume independence. Okay. All right, so let's talk about the probability that A wins. All right, so first of all, it's possible A draws the first white ball, then A wins, right? So this first case, A would draw a white ball. So the probability of drawing a white ball from 21 balls is 13 out of 21. Only one ball, okay? That's the first case. Then the game stops because A wins already. And the second case is when A didn't draw a white ball. But because we're talking about the probability, the event that A wins, so B, C would not draw a white ball. Okay, they have to draw a red ball. So the probability that A draws a red ball is 8 out of 21. And then you have a B again, okay, using independence, right? And you are putting balls back, so the probability of getting a red ball is the same. So here we have A, B, C. Yeah, here A draws a white ball. And then A draws a white ball for the second case. Okay, and the game stops. So that's the second case. And third case is when ABC, nobody draws a white ball. And finally, on the seventh draw, A draws a white ball. So we would have 8 out of 21 to the 6 ABC, right? And then lastly, 13 out of 21. So here is like ABC, all of them draw a red ball, and finally A draws a white ball, and so forth. Now you can see the pattern, okay? So next case would be ABC. You have 9 of them, 8 over 21 to the 9th times 13 out of 21. And it can go on forever because you're replacing those balls. So it's going possibly going forever, right? Okay, so here we have a seemingly complicated summation. It's actually infinite summation. But we can do something, make it a little bit better. First of all, 13 out of 21 is a common factor, so let's move it out. And inside, you have 1, right? So 13 out of 21 from the first term. You move it out, you get 1 here. And then 8 out of 21, I'm going to raise the power by 3. Then the next one, 8 over 21, raise the power by 6, and so forth, forever. All right. If you have taken mass 185, you would realize that this is the geometric sequence, actually geometric series, the sum, geometric series. All right. There's a formula to calculate the sum, but I wanted to introduce it here just for the sake of reviewing, and I think it's kind of interesting. So let's start with a general geometric sequence, possibly not possibly finite. Okay, so let's do that. We have so A and A times R, A times R squared, dot dot dot, A times R to the n minus one. So you have n terms. Okay, let's call the summation. I'll actually just write the summation because I want to call S to be something else. So you have the summation, and we try to get the formula. Okay, we try to get the formula. And you can move out A, and the left side, the right side, the leftover is 1 plus R plus dot 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 plus R to the n minus 1. So the key is to figure out that. So let's call it S. All right. So to find that, a trick is to multiply this S by R. So R times S. And you have R plus R squared plus dot 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 plus, I'm going to write one more step, one more term other than R to the n, R to the n minus 1. Okay, so this term comes from the previous one here, R to the n minus 2. You multiply by R, you get R to the n minus 1, right? So again, here we have still n terms, okay? Even though I wrote one more term here, but there's n terms. Now I'm gonna subtract second equation from the first. So left side would get 1 minus R times S. And then you'll see all the middle terms will cancel out. You would have 1 minus R to the n plus 1. So hold on a second, not n plus 1, it's n. Okay. So I get S equals 1 minus R to the n over 1 minus R. I notice that this n is 1 bigger than n minus 1. Okay. So this one is 1 bigger than that. So if you have something like 1 plus R plus dot 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 plus R to the n, actually you have n plus 1 terms. So it should be 1 minus R to the n plus 1 over 1 minus R. Okay, so be careful with that. All right, so we have this, it's called partial sum. So let's denote it by S sub n. Okay, so S, here's n minus 1. Oh, n, and let's put Sn here. It's called partial sum with n terms. Now, this one is infinite series, so we need to sort of get limit. There's a on the theorem actually, the case when R absolute value of R is less than 1, and you let n go to infinity, and R to the n would go to 0. Okay, think about half and half square, half to the third, and so forth. When the power gets bigger and bigger and bigger, and then the value gets smaller and smaller, it eventually goes to 0. So if n goes to infinity, you would get S equals 1 over 1 minus R. Okay. So we have this formula is 1 plus R squared plus dot 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 forever. That is 1 over 1 minus R. It is covered in calculus 2 as well. So that's kind of useful. Okay, so now we have that. And we only needed to use the formula for this infinite series. So you have 13 out of 21 times 1 over 1 minus 8 over 21 to the third. Okay, so ratio here is 8 over 21 to the third. Now this is our R. Okay, R is not 8 over 21. It's actually 8 over 21 to the third. Okay, so that's something we need to simplify. Yeah, the software makes different numbers. I did a few. Sometimes they get to 12 balls totally, and 8 are Y balls. Then I think 8 4 Y balls. So it would be pretty easy. 1/3 and 2/3 are pretty easy. This one's a little bit more complicated. All right, so I have 13 times 1, 13 to 21 times the bottom. So 21 minus 8 to the third over 21 squared. And I think I still need, let's see, I still need 21 to the square on the numerator. So 13 times 21 squared. And the bottom is 21 to the third minus 8 to the third. Okay, so let's figure out those numbers. I know 21 squared is 441. And the bottom, what is bottom? 21 to the third minus 8 to the third. I get 8,749. 8,749. A little trick. We know, well, it's a formula. It's good to introduce as well. So these problems need a lot of background in mathematics. A to the third minus b to the third equals a minus b times a squared plus ab plus b squared. Okay, if you're not sure, you can expand the right side and do a lot of cancellation. You will get the left side. So what I'm saying is that this number 8749 comes from 21 to the third minus 8 to the third. So it's 21 minus 8 times whatever that number is. Okay. It's 13 here. So this number is divisible by 13. So I can cancel out 13. What do I get? So this number 8749 divided by 13, 673. So it's 441 over 673. The numerator is 21 squared, so 3 and 7, okay? And the bottom is not divisible by 3, it's not divisible by 7. So that is like simplest form. All right, so let's put it inside. How do I do that? Okay, so put it here. 441 over 673. So that's the probability that A wins. All right, let's get rid of this part. Maybe I'll just erase everything. All right, let's work with probability of B wins. Okay, so B wins. That means A didn't get a y ball at the beginning. Yes, you have 13 out of 21, 8 out of 21. So this is white, this is red. So A would be 8 out of 21, then B wins 13 out of 21. And then, so this is A, this is B. And the second case is A, B, C, A. They didn't get A, B, C, A. They didn't get a Y ball. So you have 8 out of 21 to the fourth times 13 out of 21. That is for B. So B got a Y ball. And then you see the pattern, right? The next one would be A, B, C, A, B, C, A, and then finally B wins. So you have 8 out of 21 to the 7. So 1, 2, 3, 4, 7. Okay, times 13 out of 21. So the thing is that you have a power of 1 here and 4 here, 7 here. So it's a well, in terms of the power, it's arithmetic, it's 1, 4, 7. But in terms of the summation of the total summation is actually geometric. So anyway, it keeps going forever. So let's simplify a little bit. I have 8 over 21 times 13 out of 21. Moved it out because this is a common factor. And then you have 1 plus 8 out of 21 to the third again. 8 out of 21 to the 6 and so forth, whatever. Yeah, I should have remembered this summation because this summation is used here as well, but that's okay. So I have 8 over 21 times 13 over 21 times 1 over, so 1 minus r, so 1 minus 8 over 21 to the third. Okay. So I'm going to multiply let's see, what do I do? Yeah, multiply by 21. So now the bottom has 21 to the third. And you multiply by this bottom, you get 21 to the third minus 8 to the third. Okay. And I think 13 can be canceled out. But anyway, I have a 168. That's 8 times 21. And the bottom should be the same. So 21 to the third minus 8 to the third. I get 8749, but I cancel out 13. So divide by 13, 673. All right. So I'm going to put it here. By the way, I'm going to just copy this thing here. Can I copy everything? No? Ah, okay. Control C, Control B, paste. Okay. And then I change the numerator to 168. All right. The last one, you can work like that, but there's an easier way to do. We can use the complement rule. The probability that C wins is 1 minus the probability that A wins minus the probability of B wins. So it's 1 minus 441 over 673 minus 168 over 673. Okay, so I do 673 minus 441 minus 168. I get 64. So I change this numerator to be 64. And let's check. All right, so fantastic. So we're done with this problem, okay? Part A. Okay, so part B. It's without replacement. It's not replaced. So it gets a little bit interesting. It won't go forever because the balls are out. It's eventually the red balls are exhausted, and eventually somebody will get a white ball. Okay, so let's study it. So let's study the situation. Probability that A wins. Okay, A wins. So the first one, it's 13 out of 21. Okay, that's the first case when A draws a white ball. So you have a 21 with 13 out of 21, 8 out of 21, cause white, red. Okay. And the second case, similar to the first several cases, oh, actually not exactly the same because now it's without replacement. So the first ball A draws would be red, so 8 out of 21. But then B is also white because B is not winning, right? Now you have 7 red balls left. So you have A, B, C, then finally you have A, okay? A wins. So you have 20 left. We talk about drawing cards from 52 standard deck of 52 cards, right? We know one card is gone, then you have a 51 cards left, and so forth. So here, one ball is out. You have 20 balls left, and in which 7 are red, not white. And then you have a 6 out of 20, not 20, 19. And finally, A, we have 18 balls left, but there are 13 white. And then and you have A, B, C, A, B, C, and A wins. So you have 8 out of 21 times 7 out of 20 times 6 out of 19. And then you have 5 out of 18, 4 out of 17, 3 out of 16, and then finally you have 13 out of 15. Okay. Now let's consider the next case. You have ABC, 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 9 balls, but there are only 8 red balls. Sorry, 8 red balls. So after this case, A won't win because it's doomed that somebody else. I think it's B. 9. Yeah, it not in my mind now, but they're definitely A won't win. So you just calculate it out. So I'm not going to do that. Put it here. Okay, it should be decimal, round to 6 decimal G. Okay, so use your calculator with more decimal points. The B is similar. The probability of B wins is similar. That means A, you get 8 out of 21, right? And then B wins, you have 13 out of 20. And then you have a similarly 8 out of 21 times 7 out of 20 times 6 out of 19 times 5 out of 18 times, no, let me see. So A, B, C, A, that's right. And finally, you have 17 here, you have 13 white ball, so B draws a white ball. And then we have 8 times 7 times 6 times 5 times 4 times 3 times 2. I think there will be 7 of them. And you have 21 times 20 times 19, 18, 17, 16, and 15. 1, 2, 3, 4, 5, 6, 7. And finally, I have 14 here and 13. Okay, so you have A, B, C, A, B, C, A, they all draw a non-white ball, and then finally B draws a red ball, a white ball, and he wins, so B wins. All right, so calculate it out and put it here. And then you do 1 minus the summation of these two numbers. Okay. I think that's good for this problem. I'll talk about the other two problems in the class. All right. That's for today. Bye-bye.